Hello everyone, welcome to another series of the LS V8 engine table. Obviously the plan is to make this into a little coffee table, glass on top, and the goal is to make these cylinders move, go up and down with an electric motor. So first thing we need to do, I've painted this thing. I really didn't want to make a video on this because it's so boring. So I clear coated the pistons and I sanded down where the head gasket would go just for it to look pretty good and have a little bit different look than just black everywhere. It took a while, cleaning, disassembling the engine. I don't know if you guys can see, there's a big box over here with the cam, the crankshaft, some other things here and there that we probably won't use. We do want to make the camshaft into a light, so that'll be cool because you can't really see the camshaft in here. The crankshaft from here. The camshaft we need to attach, which involves putting all just everything. It really needs everything. So first thing I want to work on, especially because I really want to learn how to weld the bottom of this whole engine because we want it lifted up. But also we want it so that the camshaft can spin and you could see it, not really, but we don't really want the oil pan at the bottom. So first thing I would like to do, let me spin this over, is try and get some plasma cut plates that go on here. So I'm not very wealthy, so I don't really have a plasma cutter really, so it might be send could send, or I might send it to a friend who goes to school with plasma cutter. But the goal here is to basically cut these, but the way we need to cut them is we need to basically figure out measurements, and I really don't want to sit here and measure every little piece over here. So I'm gonna try a 3D scanning alternative because I don't have a 3D scanner either. So what we're going to do is we're going to try and take a photo, enlarge the photo based on some distances that we measure of the holes, the thickness, and we're going to try and basically line everything up. So, and by the way, the whole point of these plates is that so we can weld on the base without having to weld on this engine. First things first, we need to get these plates going. So first thing I'm going to do is take some photos, and then I'm also going to take some measurements. Alright, so we're going to take a picture of each side. The issue is they're kind of long, so and the other issue is the warpage on the phone is pretty bad. Wow, we're pretty off here. Yeah, we're pretty off. So our scaling didn't really work whatsoever. I mean, we got this side, which was the most probably straight part of the photo. So yeah, this is pretty bad. Let me just get you off the camera. Show you guys how off we are here. So basically, this is where this is supposed to be. We're right here. We're pretty off here. So I guess that's what happens when you don't have a 3D scanner and your photos are warped. So alright, so this is a learning process. So how about we now take a photo here. So we have this area. So we're going to split it where we split it. We're going to measure this. Guys, it's 1 day later, and I think I've got it. I've taped it up. This is a new one. And look at how these bolt holes match. We're a little bit off here, but that's totally fine. Look at that, guys. Look at this. And all without a 3D scanner. That's just amazing. Look at that. Look at that lineup. Amazing, amazing, amazing. So this part is ready to send, cut, send. This part I will show you guys exactly how to do. And I will go through the exact process I went to get through this. It took a little bit of trial and error with this one, but now I could exactly tell you guys what needs to be done. So let's get started. I'm going to put you on the thing. On our mount, I'm going to turn a light on. And then we're going to start using an app on our phone to 3D scan this and figure it out. The app is called Realityscan. This is what we have over here now. We're going to open up the app, and I've already got this project. This is a process project. We have the towards me bracket, which is the photo that's towards me right over here. So this is it finished up in the actual app. Look at how precise that looks, and we'll look at this on our SolidWorks model, and we'll convert this into an STL, and I'll show you guys how to do all of this. So let's get to a new project. We click plus, we do object mode. We use our standard mode, which is gonna use full camera control to scan your environment for any large stationary objects, which we have a very, very large stationary object. We're gonna take a bunch of photos, 300 photos to be exact. So I am going to begin by pulling out this engine a little bit, because I need to step around it. Alrighty. So let's begin. This is the side. This is the towards wall side is what I'm going to call it. So let's click continue here, and we have our options here. So this button on the bottom left, you can toggle on and off, which is an auto capture mode. I love this because I don't have to click the picture button 300 freaking times. This is amazing. We're going to use all 300 photos to get the most precise 3D scan we could possibly get. So let's begin. We have auto capture on, and we're gonna start taking photos, and you just go crazy with this. So I'm gonna go crazy. You literally go around, make sure you get these angles, and we'll begin. So time lapse this, and I'll get going. Alrighty guys, so we're back on the phone. We've taken our 300 photos, and we click our next button here. Now we're gonna generate a point cloud, and this might take a little bit, so be patient. I mean, it's just super cool either way that your phone can 3D scan something. I don't know why I didn't think of this before. Your phones could act as a 3D scanner, but great stuff. So yeah, just wait it out. Alright guys, so we've generated our point system, and it looks pretty crappy right now, but that's fine as long as you can see that you're basically on our little area here where we want to actually 3D scan. So we've created this,
and we move on to images. This is our point system, and the green means good, as in we've gotten enough points here. The orangey red means something's like not very well scanned, but we could tell that we have some pretty good point system here. So we're gonna move and click next, and then we're basically gonna choose where exactly our what we want to capture and basically save. So this is gonna save our rendering time a lot. So let's zoom out here and move that. Yeah. So you just basically choose your area here, and it's gonna eliminate all these, all that noise, which is gonna be helpful. So let's keep going here. That's pretty good. That's pretty good. That's pretty good. All right. I like the way this looks. So, yeah, we're ready to process. And then you choose your name. I'm going to do bracket close to wall. I know it's not a bracket, but I'm going to call it that. And then generate water type mesh. So this, I toggled this off before. Generally fully closed mesh. Note that this may result in lower quality textures and geometry in the automatically filled closed area. So I would toggle this off because we basically want to create an STL file, and it's going to get really complicated if we have open areas. So definitely do the water type mesh. And this will be easier to create an STL file, a more accurate STL file. And then we want mesh resolution high, smooth mesh, finer details with the smooth. I mean, if it smooths it out, I think what it does is it'll average everything, all the points out, which makes it more, I guess, accurate for us in terms of what we want to measure. So 8K is pretty good. So we'll process the project. It'll take some time. And then once you've processed a project, send this to your email, to your computer in some way. It'll send as a zip file, and I'll go from there. So once you click process project and it processes, this is going to take a little bit. You send it to yourself. You could download it and send it, and it sends as a zip file, as a GLB file, and we're gonna go on the computer and go on from there. So process project, and it's going to take some time, and then you would basically, as I've done here, you'd click and you'd click export 3D model, and you'd basically choose what to send it to, which would be yourself on your email, somehow get it to your computer basically. The other thing is, once you've completed this, it'll look a lot more messy. And basically what I would do is I would grab this tool here that I've gotten to, and you'd basically choose, for example, let's see here, I don't want this, so I'd choose this and snip it off, and it would snip it off just like that. So do that, snip out all your noise out, so that you can get a simple file.
Alrighty, so we've sent ourselves the file. It's a GLD, not a GDL file. So what we can do now is we want to convert that to an STL. And to do that, we simply write GLD to STL, and we go to this. I like this one. You can choose whatever you want. Convert 3D is what you use. So select your 3D model. All right, so it is now going to convert. So we're gonna call this close to wall and save it. Alright guys, so I made a whole freaking video on this, and it was on the screen about the converting thing, the convert 3D screen. So I was just talking in it, but here we are. I've made it, you know, but I'm basically going to explain how to do it. So what you're first going to do is you're going to click File, Open, and you're going to open the file, the STL file you've just made. And it's going to come out something like this. It's going to look like this. So let me just change it up a little bit. So here it is. This is what it looks like. It's really good, actually. We got a lot of points here. As you can see, it looks great, but the issue is it's not going to be to scale of what you want. So you're going to be using a lot of this measuring tool, and if you don't have mesh modeling here, you're going to right click on anywhere on this tab over here, click tabs and select and check mark your mesh modeling tab, which you do want, because we're going to also be using this scale option over here. We're going to basically be scaling this up and down. So I would take a measurement of whatever you need. You could do horizontal, between points. I wouldn't do between points actually, but what I did was I went from this side to this side. So obviously you click measure. I would zoom in here a little bit more, and you basically take some points here to here. So mine was 177.8 millimeters. It's going to be a lot smaller. I think that's why I had it at like 0.00 something. It was super small. And basically get your points, write these down, and get some more. You know, like I did a couple. So I did like bottom, center, and top, I guess. So this is, you see how it's different, 182, because there is some noise. I'm also doing this real quick, so I'm sure I'm not clicking the right points. But yeah, basically average it out. Like maybe even what I did here was I also got this point, so here to here, and I took a measurement downstairs too, and I knew what I needed. And you write down what your measurements are, and you average it out. Maybe 3 points, 2 points, whatever you want, and you take the average, and basically you do some math. You know, x times what you have. So the x would be your scale. X times what you have equals what you want. And you know what you want because you've taken a measurement downstairs or wherever. So you would basically divide those two numbers. You would divide what you want divided by what you have as your measurement, and you'd get your scaling. So you'd click scale, you'd click your body, and you'd write down. You could even do the actual math here. You know, you could do your division here. So you'd scale it, and then you'd measure again, and you'd see if it worked. If not, you'd do the same thing. You take your averages. You would basically have what you have, or divide what you want by what you have, and you get your scaling number, and you scale again. For example, if I wanted this to be 100 millimeters long, and I had it at I don't know, it was 1 millimeter. I calculated. You do 100 divided by 1, and you get your scaling, and it would be multiplied by 100. So you'd click scale, and you'd click 100 here, and that's what you would do. So once you've had that, and while you're doing this, I would definitely go in this section. Actually, I did actually really enjoy having this because you can kind of see where the turn goes. You can't really with the other side, or with the other option. So then you'd basically make your body.
which if we hide this, would turn out like this. And what you'd do is let's show it again. You would click sketch, make a sketch. You would choose a top plane. And I think it chooses your flattest area, which was really convenient to me. If this doesn't happen, you may need to start moving the whole thing around or make a plane based on, this, and you try and line it up. I think what was really convenient here is when SolidWorks actually opened this file, it chose the flattest part as my top plane, which was really helpful. So actually it doesn't look too flat. Look at that. Wait, now that I'm looking at it, it does not look too flat. Let's click top plane here. Yeah, it's actually not that flat. It's probably why it was actually kind of off. So this is actually really interesting. So I would actually rotate this and look at it. Make sure you look at this, because clearly I didn't, because I assumed that this was SolidWorks did a good job at making the top plane, and it really didn't. So to rotate it, you would use the move copy bodies in the mesh modeling option. You'd scroll down. I don't know why this pops up, but you'd scroll down, you'd click translate/rotate. You'd select your body, and then you could start rotating however you want. So you'll have a preview, moving it up and down, rotating it, whatever you need to get that perfect lineup. So, you now have it lined up. You can click your sketch, you click your top. You would click your top plane, or whatever plane you're using, and you'd start tracing it out. So I would go in this option for this, which we are in this option, and you would start tracing it out. So it would look something like this. You can't really see it. I'm gonna make it. Yeah, you can't really see it, but it's there. It is there. You would trace it out back there. Choose your circles. Obviously, you know how long your circles are, what the diameter of your circles are, and whatnot. And you trace it out using your sketch tools. I literally only use the line and the spline. And once you get that closed body, it'll basically, the whole body will darken up, and you can extrude boss base it. And then add your circles, or you can add your circles before that, whatever you want to do. So trace it out. It's really the easiest thing you could do. That's all it is. And you trace it out. I 3D printed it, and it worked great. It's lined up. I did make a video, so you guys can see the video. And it's amazing. You could send this to Send. They take the step files, so you can file, save as a step file, and send it to Send. I might send it to someone local. They'll do it cheaper. So look at your local options, obviously, because you don't have to pay shipping, or they're just better with prices. Guys, I really hope this helped. God bless, and hope to see you in the next video where we keep building this engine.